For the supervised learning, we'll use house price predicting example. We have 4 houses and they have properties like size, bedrooms, distance, and price. What we have to do is predicting the price of the house based on their properties. Let's say we have a house with 2000 square feet of size, with 3 bedrooms, and with 6 km distance to city. So what do you think would be a price for this house? Without programming or doing any calculation, I'll try to predict the price of this house. First of all, as the size increases, the price is also getting increased, right? So we can say that this is a positive correlation. And we can say the same thing about bedrooms, because the more bedrooms we have, the more price we have. But for the distance, it's actually opposite, because as the distance increases, if you can see, the price is actually getting decreased, like up to the table, right? And that's why we can say that that's a negative correlation. Based on my simple observation, I will say that this house will be around 300,000 maybe. And let me tell you why. When you look at the third house, you will see that they have the same amount of size, which is 2000 square feet. And my house only has one less bedroom than that. We should also consider that the distance has negative correlation with the price, and my house is 1 more kilometer farther. So considering all of these, I can approximate that the house will be around 300,000. Based on the dataset we have, we can define some correlations, like for example, price and size, which is positive correlation, or price and distance, which is negative correlation, or we can say price and size plus distance. So this means, for example, big house and the near city is more expensive. I mean, it's also positive correlation actually. This correlation is not about our dataset, it's just an example and I just wanted to show you. As you can see, it's not a linear correlation. In some cases, old houses can be expensive because they are antique, or they may be actually cheaper because they may need a repair. So it was just an example that I wanted to show you. The machine learning approach is actually not really different from what I did. They're exactly the same thing. Check out the formula. We have properties like size, bedrooms, and distance. B stands for bias, and these W's stands for weights. I need you to check this example very carefully. Look at the table and look at the numbers, because you really need to understand the relation between weights and properties. So for example, my weight for the size is 120, and for the bedrooms 15,000, and also for the distance minus 5,000. The weight for the distance is negative because if you remember, we had negative correlation between distance and the price. The bigger distance we have, the lower price we will have. And the B is bias, and for this example, bias will represent the base value. For the house base value, it will be 50,000. The weights determine how properties influence the outcome. If I have a house with 1000 square feet size, and also with 3 bedroom, and also with 4 km of distance from the city. To predict the price of this house, all I have to do is just calculating this formula. So I have my values, and I have my bias, and I have my weights. After this calculation, the predicted price of this house will be 195,000. I hope you was able to understand the relation between weights and properties, and how the formula works, how we determine the weights, and what's the bias. Please feel free to drop comments if you have any question or if there's something that is not clear for you. For the next video, we'll talk about labels, features, and dataset. And once we are clean with all of them, then we'll be able to start practicing and coding with Python so we can make our first model and you can have a real experience.